Alright, so this is the paper for Pure Maths 1, October, November 2021, paper 1, 2. Okay, so let's have a look for question number 1. They want you to solve this equation from theta negative 90 to positive 90. Okay, so for this question, generally, I want to eliminate the cos theta as a denominator first. Therefore, for the whole equation, I will try to multiply it with cos. So this is the original equation that I have. Alright, then the whole equation, I try to multiply it with cos, and therefore I'm having 2 cos square theta equals to 7 cos theta minus 3. And then when I try to rephrase everything, I will have 2 cos square theta minus 7 cos theta plus 3, and it is equals to 0. Okay, so from here you can see that it is actually a quadratic form equation in terms of cos theta. Alright, so from here I can try to factorize it. Alright, then for this one I'll have a 3. So this one is negative 3, negative 1, and it is equals to 0. Okay, I'll get two values here. The first value for cos theta is half. Another value for cos theta will be equals to 3. And of course, we'll ignore this part because if you take cos inverse 3, you'll get a math error where you can't get any solution from this part. Right? Okay, then next, we are trying to get the value for theta for cos inverse. So for cos inverse half is equals to 60 degrees. Alright, and they are looking for this quadrant. So that means this quadrant means that one quadrant for positive value, which means this quadrant, and another one for negative angle, which is this quadrant. So from here, you should know that 60 degree is one of the answer, and another value will be negative 60. Alright, so for the first quadrant, answer is 60 degree. Then for the fourth quadrant in negative angle, it will be negative 60. So this is how we get the answer for the first question. Okay, so question number 2. Right, so they give you, they tell you that y is equals to a function is transformed to the graph of y equals to f bracket 2x minus 3. So they want to describe fully the two single transformation that have been combined to give the resulting transformation. Alright, so first of all, you should actually try to consider the stretching part first, okay, for the transformation. So you can see that the stretching part will be somewhere here. Alright, followed by the translation. So translation is this one. Okay, so we start with the stretching part. It will be a stretch in x-axis. Because you can see that the 2 is multiplied inside the function, right? So inside the x, it will affect the value of x with a stretch factor of half. Alright, so that means the value of x will be affected and all the value of x will be divided by 2. Okay, when you're having a stretch factor of half, okay, like this. And after that, the second transformation will be a translation. Alright, so a translation, you can write it like this, a translation in y-axis, okay, by moving it 3 units down. Alright, because negative 3 means that you are moving the whole graph 3 units downwards. Alright, so this is what we have for the transformation, okay, appear here. So the keyword here will be a stretch, then the stretch factor of half, then the second transformation will be translation in y-axis with 3 units down. Okay. Alright, so now we go to the part B. They're telling you that this point lies on the transformation curve, the transform curve. And they want you to state the original coordinate, okay, to the original curve y equals to fx. So the meaning is something like this. This is my original points that I don't know, the original coordinate, which is x and y. And after it has been transformed, then we get the point P, which is 5 and 6. So according to what we learn or what we know on first part, generally the value of x divided by 2 when you go through the transformation shown here, okay, and also the value of y minus 3. All right, so to get the new value. So from here, generally you can see that when you're having x divided by 2, it is equals to 5, and therefore x equals to 10. And when you're having y minus 3 equals to 6, therefore you're having y equals to 9. So the original location for the original coordinate for this point is actually 10, 9. And after they go through the transformation shown, the point becomes 5, 6. Alright, so this is how we actually get the answer for 10, 9. Okay, then we come to question number 3. They give you a function f as defined like this. Then x should be greater than 1, right? So they want you to find the value of f composite f5. Alright, so to answer this question, you have a few options. So the first one will be you can find out the composite function f first. Then after that, only you substitute the value of 5. But for me, if let's say you straight away substitute the value of 5 throughout the composite process, then it will be much more easier. So as an example, when you are having ff5, means that you straight away substitute the 5 into the x when you are doing the composite process. Alright, so 5 plus 3 divided by 5 minus 1, you get a 2. And now you substitute the 2 again into the function f, so you get a 5. Alright, so this is how we get the value for f composite function f5. Alright, so to me this is more straightforward. Straight away substitute the value instead of you finding out the composite function first. Okay, then now we go to part number B. So for part number B, they want you to find out the f inverse x. So to find the f inverse x, you can let y equals to the function f first. Okay, then when you want to find the f inverse x, you try to rephrase x in terms of y. So when you want to rephrase x in terms of y, then you try to group all the x to one side. Okay, so you can see like this, and after that I try to move all my x to one side and then y to the right hand side. I factorize out the x, and from here you can see that I successfully rephrase x in terms of y. And therefore when you rephrase it like this already, it means that you already get the function for inverse f. So it will be x plus 3 divided by x minus 1. And you can see that this is exactly the same like what we have for the function fx. Alright, but this is the correct answer, okay? Okay, so we come to question number 4. They give you the equation for dy dx, and they tell you also that the curve passed through a particular point here. They want you to find the equation of the curve. So equation of the curve means that they want you to find the y. Okay, so they want you to find the y here. Okay, so to find the y from dy dx, you need to do the integration part. You need to do the integration process, right? So to get a y, you need to integrate the dy dx, which means that it is actually 8, and then 3x plus 2 power negative 2. Alright, so I will take out the 8 because it is a constant, so I just take it out. Then I try to integrate the function here. So the power plus 1 become negative 1. So you have to divide it by a new power here. And then also you need to differentiate the thing inside the bracket. Then you divide it by the 3. You get a 3, right? So you divide it by 3. And then you should have a plus c at the end of the equation. Alright, so you can have a look like this. So you're having actually 8 divided by 3, then 3x plus 2 plus c. And of course, now I want to get the value for c. So to get the value for c, you have to substitute the point into this equation. So from here, you know that the 2 is actually the value of x, and this one is actually the value for y. Okay, so I try to substitute it. So y equals to 17 over 3. And then you substitute x equals to 2 plus c. Alright, so you try to simplify it, you will get the value of c, which is equals to 6. And to show them the final answer, they are asking for the equation of the curve. Therefore, I will rewrite it again in a proper equation form. So that means I'm having 8 over 3, 3x plus 2 plus 6. Alright, so this is how we actually get the equation for the curve. Okay, so question number 5. They give us the first, third, and fifth terms of an arithmetic progression. So I think this is important. Alright, so the arithmetic progression. They are 2 cos theta, negative 6 square root 3 sin theta, and also 10 cos theta. 10 cos x, sorry. So where the x is between pi over 2 until pi. So first they want you to find the exact value of x. Okay, so generally we should know about this one. Okay, so for this arithmetic progression that they give us, right, we are having 3 terms here, which is 2 cos x, negative 6 square root 3 sin x, and also 10 cos x. But please take note that this is the first term, this is the third term, and also this is the fifth term. Alright, so that means from first to third term, right, the common difference here is actually 2d. And from third to the fifth term is also 2d. So you can see that if I take third term minus the first, the answer will be equals to fifth term minus the third, because their difference, their distance or their common difference is the same, which is 2d. Alright, so from here I will want to form this equation. So I take the third term minus the first term. It will be equals to the fifth term minus the third term. Okay, so when you try to minus, so minus negative become positive. Okay, so this is minus negative 6 square root 3 sin x, it will become positive. Okay, alright, so from here, I try to group all the cos x to one side and all the sin x to one side. And you will get actually the negative 12 square root 3 sin x equals to 12 cos x. And now I would like to group all the variable x to one side, then keep all the numbers to the right. Okay, so from here, very clearly that you can see I get the equation of tangent x, which is equals to negative 1 over square root 3. Okay, and now we want to get the answer for x. Okay, and they're asking for the exact value. So I think you have to highlight the word exact value. Okay, so to get the x, right? Okay, they are having 1 square root 3 and 2. Alright, and I know that this is 30 degrees. This particular angle should be of 30 degrees. So for this 30 degrees, it should be pi over 6. And for this one, it should be pi over 3. If I want to get negative 1 over square root 3, right? So the basic angle for 1 over square root 3 will be for tangent, alright? So it will be 30 degrees, which is pi over 6. And this is for basic angle. And for the x in our question here, they already mentioned just now that the x is between 90 degree to 180 degree, between pi over 2 to pi. So that means this is in the second quadrant actually. So to get the answer in the second quadrant, we are actually taking pi minus the basic angle. And therefore, your final answer for x will be 5 pi over 6. Alright, so this is what you have for part number 1. So please take note that they are asking for exact value, therefore you cannot keep it. You have to keep it in the pi form. You cannot put it into the decimal number. Alright, so this is what you have for part A. Okay, so once you're done for part A, let us continue to part number 2. So for part number 2, they are asking for the exact sum of the first 25 terms of the progression. Again, please highlight the word exact sum. So that means your final answer should be in pi form or short form. It cannot be in decimal number terms, right? Okay, so exact sum for the first 25 terms of the progression. First of all, we need to know the first term. So first term is actually 2 cos x. So the value for 2 cos x will be 2 cos 5 pi over 6. Alright, so if you try to figure out the value for 2 cos 5 pi over 6, that means it is cos 30 degree, right? You should have square root negative 3 over 2 lah, because 5 pi over 6 is in second quadrant and cos is negative in second quadrant. By the way, you can actually press calculator to get this value lah. Alright, so sorry, I make a mistake here. It should be negative 2. If I write it in proper way, it should be 2 multiplied with negative square root 3 over 2. And therefore, your A is negative square root 3. Okay, so once we have the A, now we want to get the D, the common difference. Okay, so how can I get a common difference? So again, if you refer back to what we did just now, you can see that we are having 2D lah. So 2D is third term minus the first term. So you can get the D from here. Alright, so what am I going to do is that I will try to write out 2D is equals to, you can put it either this side or either this side. Both of them are also 2Ds. Alright, so maybe I put it here. So negative 6 square root 3 sine 5 pi over 6 minus 2 cos 5 pi over 6. Okay, alright, so negative 6 square root 3 sine 5 pi over 6 is half. Okay, that means sine 30 degree in the second quadrant, it is still a positive half. Then minus 2. Then cos 5 pi over 6. We already get the value just now, which is negative square root 3 over 2. Alright. Okay, so from here, I would like to try to simplify everything. Okay, so this one I will have negative 3 square root 3 plus square root 3. So negative 3 square root 3 plus square root 3. So this one is something like negative 3 apple plus 1 apple, and eventually you will have negative 2 apples. Okay, and please take note, 2D is negative 2 square root 3. Therefore, what is the value for D? So the D will be negative square root 3. Okay, so this is one important value. And this is another important value for A. Alright, so by using these two values, we can find the sum of the first 25 terms. So it will be n divided by 2. Then 2a plus n minus 1, which is 24. And then d. So d is square root 3 negative. Alright, so we slowly and simplify carefully. I'm having negative 2 square root 3 minus 24 square root 3. Okay, then again, This one, you just assume that you're having negative 2 apple minus 24 apples. So eventually, you are having negative 26 apples. Okay, so you multiply these two values together, and eventually they will give you a value which is negative 325 square root 3. Alright, so this is the exact sum. You cannot change it become decimal place because for this question they request for the exact sum. That means you have to rephrase your answer in the try form or third form. Okay, so next is question number 6. Alright, so they give us some information here. The second term of a geometric progression is 54. So I think this is the first information that we have from here. Alright, so if it is a geometric progression, you can form an equation by using this information, which is AR equals to 54. Or you can replace it as A in terms of R, which is 54 over R. Alright. Okay, so this is the information I can get, or equation I can form from this sentence. Right. And the second information given here is the sum to infinity of the progression is 243. So the sum to infinity for a geometric progression will be A divided by 1 minus R. And it is equals to 243. So you can let A equals to 243, 1 minus R. Alright, and this can be the second equation. The common ratio is greater than half. So this is the third information that might help us to choose the correct ratio later when we try to solve it. And next, they want you to find the 10th term, giving your answer in the exact form again. Alright. Okay, so now, since we are having these two equations here, okay, and before we can get the 10th term, we need to solve for A and also the R. Okay, so let us start now. If you look at equation number 1 and number 2, right, generally they are A equals to something and A equals to something, so you can let 1 equals to 2. So from there you have 54 over R equals to 243 minus 243R. Alright, then you bring the R on the left over, becomes something like this. And again, if I try to rephrase everything in on the left hand side, then I will get something like this. Alright, so from here very clearly you can see that it is actually a quadratic equation in terms of R. You can use the calculator to help you so that you can try to simplify it if you want, or you can use the calculator. You can use the calculator to help you to solve it if you want. Or if you don't want, then you can use the formula for quadratic to solve. Okay, but before that, maybe I want to simplify it first. Okay, so you can try to find out and see how can we simplify this equation further. Alright, so I divide everything by 27. Then I will realize I will get an equation like this 9R squared minus 9R plus 2, and it is equals to 0. So you can see that if you try to simplify it, it will be much more easier for us to factorize. Right? So from this case, I'm having 3R and also 3R. One is 2 and then one is 1. Both are minus. Okay, so when we go until this step, it is very clearly that you have two values of R. The first one will be R equals to 1 over 3. Another one will be R equals to 2 over 3. Okay, then for these two values of R, right, we will actually ignore the first one, which is 1 over 3. Why? Because of the information given on top in the question saying that your common ratio should be greater than half. Therefore, there's only one value here, which is greater than half. It is R equals to 2 over 3. Alright, so once you have the R, you can continue to get the value for A. So A will be equals to 54 over 2 over 3. Right, so you can get a value for A. If you didn't do any careless mistake, it should be 81. Okay, then now you try to answer the question. They want you to find the 10th term. So the 10th term will be AR power 9. So it will be 81, then 2 over 3 power 9. Alright, so again, by pressing calculator, you'll get the answer, which is 512 over 243. So we'll keep this in the fraction form as they are asking for the exact form. Alright, so we are not going to change it become decimal places. So the final answer for this will be a fraction, which is 512 over 243. Question number 7. Okay, so they give us a diagram and then they give us some explanation about the diagram. So AB and AC are both 15 cm. Point P is the foot of perpendicular, okay, from C to AB. And the length of CP is 9. So an arc of the circle with center B pass through C and meets AB at Q. Alright, so first part, they want us to show that the angle ABC is 125 radian, correct to 3 significant figures. So the angle ABC is actually this one. Okay, so this is the angle ABC. Alright, and we want to prove that it is equal to 1.25 radian. Okay, so maybe before I can find out the angle ABC, first I can find out the angle BAC first, this one in blue color. Alright, so to get the answer for BAC, I'm using this triangle, the blue color triangle, to help me. Alright, it is a right angle triangle, so it will be quite easy and quite useful for us, okay, to find the angle BAC. Alright, so now if let's say I'm looking for, I have the 15, this is the value for hypotenuse for the triangle, and this is the opposite length. Alright, so I can use the result for sine. So sine angle BAC is actually equals to 9 over 15. Okay, and therefore the angle BAC is actually equals to sine inverse 9 over 15, you'll get 3 over 5, which is 0.6. Okay, then I will not change it to decimal place yet. I'll just keep it in sine inverse 0.6. And now by using this result, I know that this angle and this angle should be the same actually. Okay, because they are actually having the same, it is the isosceles triangle, this side and this side. So these two angles should be the same. Okay, and by using the property that the total angle in a triangle equals to 180, all right, therefore I can find out the angle of the ABC. Okay, so I'm using the to find the angle ABC, I use the property that the total of these three angles should be equal to 180 now. So I will take 180 minus the blue angle BAC. Then I divided it by 2 because these two angles should be the same. Alright, due to the reason that the triangle is an isosceles triangle. Right, so by just pressing calculator, you will get the value for angle ABC, which is 1.249045772. And if you correct it to 3 significant figure, you'll get a correct answer, which is 1.25. And this is tally with, or this is aligned with the answer that they want us to prove. Okay, all right, so this is how we actually solve for part A. Yeah, right. So maybe for part A, I will try to label everything here. Okay, so from part A, I already know that this angle is actually sine inverse 0.6. And then for these two angles, they are the same, which is 1.25 radian in short, right? Okay, then now let's proceed to part B. Okay, so for part B, they want us to calculate the area of the shaded region, which is bounded by the arc CQ and the line CP and PQ. Okay, so if you have a look for the shaded region, right? Okay, generally, what we can do from here is you can try to figure out, or maybe you can try to write out the steps. Okay, so before that, an area of the shaded region. All right, so from here you can see that you can use this is the sector. Okay, so you can use the sector BQC minus this small triangle here to get the shaded area. All right, so when you want to minus a triangle, means minus a triangle BPC. Okay, so generally this is our overview of the steps that we should carry on. Okay, to get the answer. All right, so now we will slowly figure out and see what are the values that we need. Okay, so to calculate the area. Okay, so first of all, we need to have the area of the sector BQC. So for sector BQC, you need the R. The R will be this one and also this one, which is the length of BC. Okay, so maybe we can try to find out the value for BC first. Okay, so we have many ways to find out the value for BC. Okay, so it depends on what kind of method that you want to use. All right, if you want to find the BC, you can use the cosine rule. Okay, by having this, you're having this angle, the length, okay, and also is equivalent or it is enough for you to find the BC. That's one method. Another method is I will refer to this particular triangle. Okay, so I will refer to this particular triangle. Then from this triangle, right, I know that for sine 1.25, to have this sine 1.25 is actually equals to 9 over the BC. So to me, I will choose this method because it is slightly shorter. All right, instead of using the cosine rule, it is quite long. Okay, so I use the ratio in the triangle, therefore I can get the BC easily. All right, okay, so this is my something that I want to use. I just keep it like this first. Okay, so I know the BC already. Then sector BQC means half R square theta. So you already have the R is BC, right? So theta you have it already, which is the angle ABC. Okay. Then now we refer to this one, the triangle BPC. So for the triangle BPC, you need to have the formula half multiplied with base. This is the base. Okay, half multiplied with BP multiplied with CP, the height, base times height. So you have the length of CP already. Okay, then you can get the length of BP lah. So to get the length of BP, again, I'm trying to use this one. So cos 1.25, it is equals to BP. Oh, sorry, maybe I shouldn't use cos. I should use tangent. Right, tangent means 9 over the adjacent. So BP. Okay, maybe I use tangent. So tangent 1.25 it is equals to 9 over BP. So from here, I can get the length for BP also lah. So the length for BP will be 9 divided by tangent 1.25. Okay, all right. So by using this small triangle, actually I can get the value for BP and also the value for BC. Okay, so this one is tangent. All right, so now these two value will be important for me to get my answer later. All right, okay, so I will rephrase everything again, then write it in the proper manner. Okay, so this is for my part 2. Okay, so for part 2 is the shaded area, the area of the shaded region. Okay, so will be actually equals to the area of sector BQC minus the triangle of BPC. Okay, so for the area of sector BQC, it will be half R squared. The R squared, the R is BC lah. So the BC will be 9 over sine 1.25. So R squared. Then theta. So theta will be this one. So the theta will be 1.25. Okay. Then minus the triangle area. So the triangle area will be half VP. Half base. Base is 9 over. Sorry, let me rewrite it again in a better way. Okay, so 9 divided by tangent 1.25 multiply with the height. So the height is 9 cm. Okay, so by having these two values, right, when you try to press the calculator and correct it to 3 significant figure, you will have 42.8. So the area will be 42.8 for this one. So this is the answer for part B. Alright, and it is worth mention that for this part, when we are trying to do the calculation, right, we are using the 1.25 all the while. Okay, so we are using 1.25. So that means when you press calculator, okay, 1.25 into this equation, then the final answer that you get is 42.8. All right, then they might have some other students, they are using the original value. Instead of 1.25, they use the original long value, which is 1.249045772. So that means that if you substitute the 1.25 here, by using this long value, your final answer for this question will be 42.7. Okay, and for this case, both answers are correct. The marking scheme will actually accept this both answer. Alright, so you can use 1.25 because of the question actually asks you to prove that the angle is 1.25 at first. So that means you are allowed to use the 1.25 in your second part calculation here, and they will accept the answer. Alright, but some students they will use the long value lah. So if you use the long value in your calculation for the second part, then of course you'll get slightly different answer, which is 42.7, and they will accept both answers. Alright, so this is how we actually get the answer for question number 7. Okay, so now we have question number 8. Alright, so for question number 8, you can see that they give you the expression like this, and they want you to expand it. Alright, and before you expand, they give you actually the information that the coefficient of x squared is equals to -15. Okay, so find the possible values of a. All right, so for this question, generally, you need to analyze it a bit. You need some analytic technique a little bit, okay, before you can start the steps. All right, okay, so when you are having 4 plus 2x, it is power 1, so you don't need to expand anything. Okay, but for this bracket itself, I think you we need to expand it. All right, because it has until x, the bracket power 5. All right, so now if you want to expand the whole thing for 2 minus ax power 5, of course you can. All right, but if let's say I want to save my time, then I will just focus on what are the terms that I want to expand and I want to get only. So I will expand only the terms that I want. All right, okay, so if you have a look for the 4, okay, multiply with something here, right, to get the x squared. So that means the something here should be something with x squared. So that means when I want to expand this bracket, I will try to expand something with x squared here, where it will be 5c2, then 2 power 3, negative ax power squared. So that later when I expand the whole terms here, I will get something with x squared, and x squared multiplied with 4. I will still get a term with x power 2. Okay, then after that, you will refer to the 2x. So for 2x, you need to multiply with something with x to get the x squared. All right, so again, how can I get the x here? So you should have 5c1, 2 power 4, negative ax power 1. All right, so I will focus on only these two terms. All right, so if let's say you found that you not able to identify what are the terms that you want to get, then you can expand the whole thing, and of course the steps will be longer. Okay, so now let's continue from here. Okay, so try to press the calculator and simplify all the constant. All right, so what are we going to have here is you will have 80 a square x squared. And for this term, if you try to expand and simplify all the numbers, all the constant, you have 80 a power 1 x power 1. All right, then now we want to further expand it. So 4 multiply with this term to get the term in x squared. So when you expand it, you will have 320 a power 2 x power 2. We do the same thing for 2x, multiply with the next term here, and you also will get something with x squared, which is 160a x squared. All right, then maybe I will try to factorize out the x squared so that you can see the coefficient of x squared clearly. So this is what we call as coefficient of x squared. And in this question, they also give you the coefficient of x squared already, which is negative 15. So that means you can let this 320 a squared minus 160a equals to negative 50. All right, because again, you can see that from here, this is actually the coefficient of x squared. All right, so we get this equation. And again, if you have a look in detail, you will realize that it is actually a quadratic equation. Okay, but before I factorize it, maybe I can simplify it first. Okay, then you try to factorize it from here. And therefore you try to solve for the a. So you have two possible values of a, which is 8 or 3 over 8. Another one will be 1 over 8. All right, so this is how we actually get the values of a. Okay, all right, so next we proceed to part number 2, part B. Okay, so for part B, they are saying that it is given instead that in the expansion, so this is still the same expansion, the coefficient of x squared is k. Okay, so in part A, they tell you that coefficient of x squared is negative 15, but now they tell you that the coefficient of x squared is k. So it is also given that there are only one value of a, which leads to this value of k. Okay, so maybe you can highlight the word one value of a. Then from here, they want you to find the values of k and also the values of a. Okay, So now we shall start from this part. The coefficient of x squared is k. All right, so where should we start is maybe we can refer back to the coefficient of x squared that we get in first part. This one, okay? All right, so instead of negative 15, maybe what we can do is that we will let the coefficient of x squared, okay, we let it equals to k. So from there, we still get a quadratic equation, but it is in terms of a and also the k now. All right, then to continue, here they say that there's only one value of a, which leads to this value of k. So one value of a means that there's only one root in your quadratic equation. So this is your quadratic equation, and in this part they tell you that there's only one root. So for quadratic equation, what is the formula that you can link with one root? So it means that you are having b squared minus 4ac, and it is equals to 0. So what is my b squared here? Negative 160 squared minus 4a. C will be our negative k, and it is equals to 0. All right, so if you expand everything carefully here, eventually you will get the value of k, which is negative 20. All right, okay, so this is part of the answer that they request. So after you get k equals to negative 20, now please continue to get the value of a. So how can we get the value of a here? Again, you can try to substitute the k into the quadratic equation. So you're having 320a squared minus 160a, then minus negative 20. Therefore, you have plus 20, and which is equals to 0. Okay, then of course, you can further simplify it. Right, so you have 16a squared. Then for this one, you have 8a plus 1, and it is equals to 0. All right, so now you get another quadratic equation. So you can choose either you want to use quadratic formula to solve it, or you can factorize it if you want. All right, so for here we are having 4a and 4a, and then I'm having 1 and 1 here. Okay, so to factorize it, I think I will have a negative value here, negative 1 and negative 1. So it also shows you that your final answer there's only one a, right? Which is correct, which is true, because in the question itself they will tell you there's only one value of a. So the value of a that you get should be equals to 1 over 4. Right, so this is what we have for question number 8. Okay, so question number 9. All right, so they give you the volume of a large circular mold of iron, okay, of radius r meter, which is molded by the equation. So they give you the equation for volume of volume. All right, so this is added to the mold at the constant rate of 1.5 meter cube per second. Okay, so maybe from this wait, right, so this is one of the important information. Okay, so you can see that it is 1.5 meter cube per second. So the meter cube per second actually tells you about the volume. So that means when you want to write it in symbol form, it will be dV at a constant rate, right? So over dt, it is equals to 1.5. So to me, I think it is important for us to write out the correct formula for the rate first. Right, so for this case, we are having dV over dt equals to 1.5. Okay, so for part number A, they want us to find the rate at which the radius of the mold is increasing at the instant when the radius is 5.5. So they actually want you to find out the rate of radius increasing. Yeah, so that means what they want us to find is the dr, radius is r over dt. Okay, so this is what we want to find out. And then this is what they give us, and also with the volume formula. All right. So from here, generally, you know that later we have to apply a chain rule to get the dr over dt. So for the very first step, we need to find out the differentiation for v, okay, over r. This is my original equation. I want to find out dv dr. Okay, so copy the constant, the power 3, you put it in front, become 3. Copy the bracket, power minus 1 become 2. So the negative 1 here is a constant. So when you differentiate the constant, it becomes 0. Okay, so from here, you can further simplify it where you are having 9 r minus half power 2 divided by 2. Okay, so once I have everything ready already, so I want to start finding the dr over dt that is requested by question. So by using the chain rule, it should be dr over dv multiply with dv over dt. So how I know that it should be dr over dv and dv over dt? It is because of according to the information given in the question. So this is the variable related, okay, in the chain rule. All right, okay, so now I want to have the dr over dt. So that means this one, you have to make it upside down, and you are having 2 over 9. You have to substitute the value of r. So the value of r is 5.5 here. So it will be 5.5 minus 0.5. Half is 0.5, right? Then square. Then multiply with dv over dt here, which is 1.5. All right. Okay, so by just pressing calculator, you'll get the answer, which is 1 over 75. Okay, meter per second, or you can write it as 3 significant figure, which is 0.0133 meter per second. All right, so this is actually the rate of change for the radius. Okay, all right, and we know that it is increasing because of the value that we get here is a positive value, so we fulfill what they said. All right, it is in increasing rate. Okay, then now we continue to part B. Okay, so for part B, find the volume at the instant when the radius is increasing at 0.1 meter per second. Okay, so now again you can see the keyword radius is increasing. So that means this one means that the dr over dt is equals to 0.1. All right, so they are asking you when dr and dt is equals to 0.1, what is the volume? All right, okay, so first I will still using back the chain rule that we have just now. Right, so where dr over dt, it is equals to dr over dv multiply with dv over dt. Okay, so dr over dt is 0.1. So you just put it as 0.1. It is equals to 2 over 9. And then r minus 0.5 squared. So at this part, okay, when dr dt is equal to 0.1, we actually don't know what is the value of r. So we'll just keep it as r first. All right, then multiply with dv over dt, it is still 1.5. Okay, so why is it still 1.5? It is because of, if you look at the question given on top, okay, so if you look at the question given on top, they are talking about the constant rate. So that means the dv dt is constant always. So it is always 1.5 and it will not change. Therefore, when you come to part B, this value, it is still 1.5. All right, okay. So now we try to rephrase everything here so that we can get a value for r. Okay, so I will bring the r over. So r minus 0.5 square, it is equals to 2 multiplied with 1.5 divided by 9 multiplied with 0.1. Okay, So I get the value 10 over 3 for this case. All right. And after that, we can continue further, okay, to try and get the value of r. So when I take square root, I will have plus minus square root 10 over 3. And I move the 0.5 over, become plus 0.5. Okay, so from here, you can see that we actually have two values. We have 0.5 plus square root 10 over 3. Another one would be 0.5 minus square root 10 over 3. And very obvious, we actually need to ignore this answer. Okay, so why do we need to ignore this answer? There are a few reasons. First one is because of it is in negative value, where the radius should be in positive. Another reason is if you look at the question, you can see that the radius should be greater or equal to 2. All right. So if you try to press this value, definitely it is not more than 2. It is not equal to 2 or more than 2. So that's why we ignore this part. Okay, so my radius is this. But again, according to the question, they're asking for volume. So you need to substitute the value of r into the volume equation, which is 3 over 2. Then your r is half plus square root 10 over 3 minus the half power 3 minus 1. Okay, so you straight away just substitute the value of r into the volume equation to get the volume. The long answer for this is 8.1287. So again, you can correct it to 3 significant figure, which is 8.13 meter cube. So this is what we have for our volume. So you need to find out the radius first by using all the information given. And after that, only we use the radius value that we get and substitute it into the volume equation. Okay, so question number 10. Right, so they give you a function, and then the domain given is x greater than 0. Right, so for first part, they tells you that the equation y equals to fx as stationary point when x equals to 2, and they want you to find the value of k. So stationary point can be either maximum point or minimum point. Okay, so when you want to find out the maximum or minimum point, generally we need the differentiation. All right, so this is my function fx. And then if I want to differentiate it, I would prefer to make it become x power negative 1, then plus 2. Okay, so to find the first differentiation, the first derivative, I'm having 2x minus k over x squared. And then differentiate the plus 2 is a constant, therefore I get a 0. Okay, all right, so when you want to get a stationary point, after you do the differentiation, you will let it equals to 0. And from here, they give us extra information. Now, when x equals to 2, then we are having a stationary point. So that means you have to substitute the 2 into the equation when f prime x equals to 0. So from there, you can get the value of k. So the value of k should be 16 if you didn't do any careless mistake. Okay, so this is what we have for part A. All right, then now we continue to part number B. For part B, they want you to determine the nature of the stationary point. All right, so to determine the nature of the stationary point, you need to go through with the second derivative. So it will become 2, okay, minus negative 2kx power negative 3. All right, so if I rephrase it again, then I'm having 2 plus 2k over x power 3, which is 2 plus 2 multiplied with 16 divided by 2 power 3. Because at x equals to 2, we are having the stationary point. So when you substitute the x into the second derivative, it should be also x equals to 2. Okay, so from there, you will get the value 6, which is a positive value. okay, positive value. So when you're having a positive value for the second derivative, then generally the stationary point will be a minimum point. So you can say that the stationary point is a minimum point. Okay, so this is what we have for part B. And after that, if you go for part number C, okay, for part number C, they are saying that the only stationary point, the point that we find out just now is the only stationary point of the curve, and they want you to find the range of f. Okay, so our original function, right, it is actually a combination of, you have the x squared, then you have the 16 over x plus 2. Okay, so far we haven't learned any method of drawing or sketching the graph. Okay, but we will just based on the diagram, based on the information that they give us. So here they mentioned that the stationary point is the only stationary point, and that particular stationary point is the minimum point. All right. So to find out the range, you need to substitute the 2 into your function to try to get the smallest value first at the minimum value. Okay, so you will get 14. So since the 14, y equals to 14 will be the minimum value for the whole graph, for the whole function. All right, therefore, when you want to state the range, it will be y greater equals to 14. All right, because the 14 itself is the minimum value or minimum point. Should be minimum value, right? Okay, so the range should be y greater or equals to 14. Okay, so this is how we actually solve question number. Okay, so let us discuss question 11. Right, so they give you a diagram here and they explain, okay, what is the value of x on the line and so on the graph and so on. All right, point A and also the equation of the curve. Okay, then the normal to the curve at point A. So there's the normal to the curve at point A, which is this one, this line. All right, so here they want you to find the x coordinate of the point where the normal to the curve meets the x-axis. All right, so they actually want you to find out this value. Okay, right, so to find out this value, generally we have to find out the equation of normal first. Okay, so to find the equation of normal, of course, you need to go through with the differentiation to get the gradient of tangent. Then only we can get the gradient of normal, then form the equation of normal. All right, so we will start with the equation first. So I'm having y equals to half x plus 7 over 10, then minus x minus 2 power negative 1 over 3. Okay, so I'm looking for the differentiation. So for the differentiation, I will have dy dx. Differentiate half x, you'll get half. Differentiate a constant value, 7 over 10, you get a 0. And then when you try to differentiate this one, you bring the negative 1 over 3 over in front. So you have positive 1 over 3. Copy the bracket, then the power minus 1 become negative 4 over 3. Okay, and then now you have to try to get the gradient of tangent. So to get the gradient of tangent at point A, so the point A, x is the 3. So you substitute the 3 into the equation, and then power negative 4 over 3. From here, you will get the value. So the value is actually 5 over 6. Okay, so please take note that this 5 over 6 will be actually the gradient of tangent. Okay, right, so for this question, we actually look for the gradient of normal. We look for the equation of normal. Therefore, I want to get the gradient of normal. Gradient of tangent, multiply with gradient of normal, it should be equals to -1 because they are perpendicular to each other. Therefore, the gradient of normal, you can write out the value correctly, which is okay, so which is equals to -6/5. All right, so now you have the gradient of normal. You have the passing point on the line of the normal. Therefore, you can form the normal equation very easily. Okay, so now I will form the equation of normal here. Where it is y minus the point y1, which is 6/5. So this particular point A is the passing point on the normal equation. So y minus y equals to mx minus x. Okay, so if you try to simplify everything without any careless mistake, then your equation of the y of the normal should be -6/5x plus 24/5. All right, this is the equation of normal. And from this question, they want us to find out this x-intercept. So to get the x-intercept on normal line means that you let y equals to 0. So when y equals to 0, the value of x that you get is 4. Okay? So this is actually the x coordinate when the normal of the curve meets the x-axis. All right, so from here, we should actually know that this particular value is a 4. All right, okay, then now we proceed to part B. Okay, for part B, okay, for part B, they want us to look for the area of the shaded region, correct the answer to 2 decimal places. So from the diagram, the shaded area is very clear. All right, so to find out the shaded area, generally, I think it will be suitable or it is appropriate for us, okay, to find out, to separate it into 2 different regions. Okay, if you want to find out the area, you should actually separate it into 2 different regions. Okay, so this is 3 because the x coordinate for A is a 3. So I have region A and region B. So region B here is a triangle where it is quite easy for us to find out the area. And the region A is bounded by the curve. Therefore, to find the area under the curve, you actually need to do the integration. All right, so to find the shaded area, it will be equals to region A plus B. So the region A includes the integration. So the limit is from 5/2 until 3 for region A. So 5/2 is 2.5. So 2.5 until 3. And you need to integrate the equation of y, the y equation, because the area is bounded by the equation. So this part is region A, then plus region B. So the region B is actually a triangle. So for the triangle, it will be very straightforward, which is half times base. So the base is this one, where it is 1 unit. 4 minus 3 is a 1 unit, right? And then the height. So the height will be from here to here. So which is the value of 6/5. Okay, so this is the area of the triangle or region B, where you take half, multiply with the base and also the height. Okay, so we continue with the integration part first. Okay, so integrate half x, you have x power 2/4. Then 7x/10. Then for this part, you need to add 1. So when you add a 1, you have x -2 power 2/3, then divided by 2/3. and you need to substitute the value of 3 and also 2.5. Okay, then for the area of the triangle, generally what we have is that we are having 3 over 5. Okay, all right, then now we try to substitute in the value here. When I substitute the 3, limit 3, into this whole equation here, I will get the value which is 57 over 20. Then minus, now I substitute 2.5 into this whole equation here, and I'll get 2.367559 then plus the value at the back, which is 3 over 5. Okay, all right, then after that, when I combine everything together, I'll get a long value like this, and I would like to change it to 3 decimal places, okay, to fulfill the request from the question. So from here, correct to 2 decimal places, it will be 1.08. So the area will be 1.08. Okay, so now we come to the very last question for this paper. Okay, they give us a diagram with a circle, and they tell us that this is a circle with this equation and also the tangent to the circle at point P. So this is actually the tangent line, okay, at point P. Right, so first they actually tell us that the tangent to the circle at point P meets the x-axis at A and B. So the x and y intercept for this particular this particular tangent is the point A and point B. All right, so they want us to find the area of triangle OAB where O is the origin. So from this question, you can see that this is the area that they want us to find. Okay, so before we find out the area, we need to know the coordinate for A and also the coordinate for B. Okay, so to know the coordinate for A and B, we need to form the equation of normal first. Oh, sorry, the equation of tangent first, sorry. All right, so to form the equation of tangent, of course, we need the passing point. We already have the passing point, which is the P, but we need the gradient. All right, so to know the gradient, I need to know the gradient of center. Okay, let me assume that the center is here, which is the C, and from center to the point that forms the tangent, it is always a 90 degree. So that means I need to find out the gradient of CP first, okay, which is the center to the P. Then by using this gradient, I find the gradient of normal. I form the gradient of tangent line. And after that, from tangent line, I can find out the A and B coordinate. Then I can find the area to the next step. All right, okay, so the very first of all, I think I need to find out the C first, which is the center. Okay, so let me start. For center, right, this is the original circle equation. To get the center in general equation, I cannot. So we have to rephrase it to standard form. All right, so before we rephrase it into standard form, what I usually do is like I try to group the x together and the y together first, and then the number to the right hand side. Okay, so when I'm having x squared minus 6x, okay, then I try to do the completing square. So plus negative 3 square minus negative 3 square for the x. And after that, we do the same thing for the y. All right, so which is plus 2 square minus 2 square. And it is equals to 27. Okay, then now the first 3 terms of the x will form a big bracket, which is x minus 3 square. Then I'm having negative 9 plus the first 3 terms of the y will become y plus 2 square minus 4. and it is equals to 27. All right, then again, I try to rephrase everything. Okay, and from there, I'll get 40. Yeah, so if I simplify further into a standard form, then I'm having square root 40 squared. Okay, so from this part, you know that the center C will be 3 and negative 2. Then the radius will be square root 40. Okay, so now once I know the center already, which is the C, therefore I want to find out the gradient of CP. Okay, so what is the gradient of CP? So P point is 5, 4. So to find the gradient, it will be 4 minus negative 2 divided by 5 minus 3. So from here, you are getting 6 over 2, and therefore the gradient of CP is equal to 3. Therefore, the gradient of tangent line, which is 90 degrees to the CP, will be negative 1 over 3. Alright, so from here, I will try to form the equation of tangent. So this equation of tangent will be y minus 4 equals to negative 1 over 3 x minus 5. Alright, then if I try to rephrase everything, okay, then I'll have 17 over 3 as the y-intercept. Okay, so the 17 over 3 will be the y-intercept. Okay, so I will want to continue maybe from here. Okay, so this is the y-intercept. Then now I want to find the x-intercept. Alright, so I come further here. Okay, so for the x-intercept, we will let y equals to 0. So from here, the x is actually equals to 17. So that means the coordinate for A will be 17 over 0, 17, 0, and the B will be 0 and 17 over 3. Because from the equation itself, we already know that this is y-intercept. Alright, so to find the area of the triangle OAB, it is a right angle triangle, right? So it is actually half multiply with the base. So the base will be the length for A, which is 17, multiply with the height. So the height will be 17 over 3. Okay, so when you further simplify, you will get 289 over 6. Or you can rephrase it, become 3 significant figure, which is 48.2. Alright, so this is how we actually get the area of the triangle OAB. Right? Okay, so you can see that generally we need to find the center first, and after that to find the gradient of CP from center to the P. Then we get the gradient of the tangent line and form the equation of tangent. And lastly, we find out the x and y intercept for the tangent line, then only you can get the area. So the process is quite long actually, right? Okay, then now maybe we proceed to part B. All right, so for part B, right, so for part B, they actually want us to find, they tell us that QR is also on the circle, and then PQR is an equilateral triangle. Then they want us to find the exact area of triangle PQR. So I think the important part is this one, the exact area. And then PQR is a equilateral triangle. If you have a look for the equilateral triangle, from the diagram, the equilateral triangle will be, okay, so we join the PQR together first. So equilateral triangle means that all the three sides are the same. Okay, and that means when all the three sides are the same, that means that the particular angle here will be 60 degree, which is pi over 3. All right. Okay, so now because we actually don't know the coordinate for the Q and also the coordinate for R. We also only know the coordinate for P and also the center. So if let's say I'm having a center here, and then I form a smaller triangle from center to P and also from center to Q. Okay, so you can see that if I want to get the triangle, the area of the equilateral triangle, it is actually 3 times of the small triangle here. Okay, because everything is in same length and also the same degree. All right, so I actually can divide this triangle equally into 3 from the center, into 3 parts from the center. All right, which also means that if I can find out this triangle, the area of this triangle, then I multiply it with 3 and I will get the answer that I want. Okay, so I want to find out the area of this smaller triangle first. Okay, all right. So now, if I want to find the area of the smaller triangle, okay, so maybe I write out the solution here for part B. Okay, so for the solution of part B, right, I need the area. Okay, so area of triangle PRQ is actually equals to 3 times of the area triangle BCQ. All right, so to get the area of triangle PCQ is actually half r squared. So the r is this one, which is the radius square root 40. So r squared, square root 40 multiply with square root 40, and then this angle. Okay, so what is this particular angle in the center? Okay, so when 360 divided equally into 3 sections, so it will be 120. Okay, all right. So that means this center part here, 360 divided by 2 regions, so you will get 120 lah. Okay, so 120 which is equals to 2 pi over 3 lah. Okay, all right. So you are having half. Okay, so look at this triangle again. It will be half AB, which is R and R, and then sine theta. So the theta in the center here will be 120, which is sine 2 pi over 3. Okay, so I try to rephrase everything. I'm having half square root 40 times square root 40, I get a 40. So sine 60 degree, I will have square root 3 over 2. Or sine 120, I also have the same value, which is square root 3 over 2. And from that, if you try to simplify it and keep it in the third form, then you will have 30 and square root 3 as our answer. Okay, so this is how we actually get the area for the equilateral triangle in part B. All right, the equilateral triangle are PRQ. Okay, so we ended the discussion for this paper. Thank you very much for watching.